Hi everyone, my name is Dr. Chuck Ver Straeten from the New York State Museum, and for today's Facebook Live event we thought that we had an idea of showing an office of one of the scientists in the museum. And as you can look over here and see, and in other places around the room, I'm a geologist. I work with rocks and fossils too. But anyway, welcome to my office. So, a geologist. It's no surprise that a geologist would have a lot of rocks and, depending on what kind, fossils in their place. And I'm going to pick up this piece right here. This is a rock that comes from the Catskill Mountains down here in eastern New York, west of the Hudson River. And this rock, when I feel it with my fingers here, it's kind of like a fine sandpaper grit right there. This is a rock that was made largely of sand that was cemented together to form sandstone. And the neat thing about this rock is this is the way it was in the rock outcrop where I collected it, is that it has these lines of red coming down through it. So that was up in the rock in the real world out there, and these that are coming down and penetrating through the sands and have a smoother texture. That was because these are clays that came down into holes here. This is where tree roots of some of the oldest trees in the world penetrated down through a sandy soil. The Devonian rocks, well, I'll talk about the Devonian in a moment. In the Devonian rocks of the Catskill Mountains, it has some of the oldest known forests in the world. If you go back to the, well, let me talk about the Devonian for a minute first. The Devonian is an interval of time that to a geologist is like a month. A month in the sense that a month is 60 million years long. And these rocks come from back about 400 million years ago. If you compare it to when the dinosaurs first appeared in the rocks, that's about 230 million years ago. So most of these rocks and fossils that are here are not quite twice as old as the oldest dinosaurs. And the Devonian is a time when land first really colonized. When plants and animals really started to colonize the land for the first time on planet Earth. And that's what we can see in the fossils that we find. All right. Couple things. I'll just pick up a few things. This is a coral here. And we call this kind of horn coral. Sometimes they're much longer and not so broad. This one grew outward more quickly, but horn coral in the sense of this. But sitting in, this would be a point here. You can see how it's tipped over time, and like a tree that leans, it wants to grow straight up. So this one, sitting in the top here, there's some shale, what used to be mud in it right now, but there was a sea anemone-like animal that lived there, a solitary coral animal, lived in the top of this cup, of this horn coral, as we call it.
Where is that from?
This one comes from central New York. From the middle part of the Devonian, about 385 million years old. Yeah. Where's another good one? Well, this isn't really clear, but if you look at these black pieces, that's all parts of a fish bone, and this is a part of two fish teeth. It's hard to tell from what you see there, but from better samples that I don't have in my office, we know that's what they're just the pieces of. And this is about 390 million years old. we were talking about roots. Here's another piece with roots right here. You can see how it's broad up here and then it gets narrower down here and branching roots come off it. After the plant died, the roots decayed away and very fine muds washed down into the hole where the roots used to be. Anyway, that's just some things about rocks. You know, I'm a geologist, and what that means is that I'm like a detective, an earth detective, earth history detective. And I'm trying to find out what New York was like back between about 420 and 360 million years ago. So part of my time working as a geologist is working in my office or working in a lab. I also am in charge of a curator of a collection of sedimentary rocks. That's my specialty in geology. I work with sedimentary rocks, rocks that were once loose sediments, sand, mud made of clays largely, or gravel that then got cemented together, or shells that then got cemented together to form different types of sedimentary rocks, sediment going to rocks. And it's in sedimentary rocks where you find a lot of fossils. Here's the top of another fossil coral from the Devonian period also. In each one of these little holes, there would be an individual, like sea anemone, sticking up out of each one of those holes right there on the seafloor.
Seen a couple fossils too.
Oh yeah, there's part of a fossil seashell right there of an animal called a brachipod. Yeah. All right. So rocks and fossils are what I learn about. And really looking at a sedimentary rock, for me, just like we can pick up a piece of paper and read these various shapes called letters that combined tell us about an idea that allow us to express things. One who's a geologist also reads rocks. Let me think, what would be a good one here? Okay, I'm going to pick up this one. So I'm just going to read rock here for a moment. This is a rock that I feel, again, is like sandpaper. This is a piece of sandstone. These dark specks are pieces of shale, what used to be mud, in the sandstone. And up at the top here is something that has this real rough and rugged looking texture to it. This is a sandstone deposited in shallow sea. These dark blotches are pieces of shale that were torn up during a storm in the shallow sea. And this is a piece of a log from one of these early trees from the Devonian period that was washed out to sea in the shallows and settled down, and it was all buried after the storm was over. So that's reading a rock, using the fossils and the other features in a rock to understand things, to understand what the world was like in the past. In that case, the result of a single storm on a seafloor about 390 million years ago. All right, let's wander around. There's a lot of things in this office. I've just been over there so far. The other thing that you see a lot of, besides posters and charts around the room, are books. And there's file cabinets over there to that side that are full of geological papers, scientific studies. And as a geologist, you generally have to know a number of different, I'm going to slip this down for a little bit. You need to have a grasp of a number of different topics within geology, even though you specialize in a certain part of geology. So these books are all about life on land and environments on land, and how sediments get deposited on land, or here, terrestrial ecosystems on land. In my case, long ago, around 400 million years ago. These books are all about lake sedimentation, what happens to sediments in lakes. This is about volcanoes. Now that starts talking about igneous rocks, but volcanoes, volcanic ash. In sedimentary rocks, sometimes you find volcanic ash layers that were explosively erupted up out of volcanoes, in this case in the Appalachian Mountains during the Devonian period. And that ash settled down out of the air in New York, or some of that ash got carried as far as from the Appalachians all the way out to west of the Mississippi, like in Iowa, where it was a shallow sea from here to Iowa, New York to Iowa at that time. This is about what happens when you weather rocks. So I have all kinds of rocks here, all kinds of books here. Words are slipping past me today. Yeah. But anyway, there's also some nice rocks here. This is a piece of limestone. And you can see all these little particles sticking out of here. Those are fossil shells. And usually they would weather away just like the limestone, but they're sticking out here because the original shell mineral called calcite got replaced by silica, quartz. And so limestone, when you have limestone out in nature and you have some slightly acidic waters, it dissolves the limestone to make caves. And that's what's happening here. The pure limestone is dissolving away, but the shells remain because their calcite shells were converted after deep burial to being quartz, being silica, preserved. This is a crazy looking rock. I like this one a lot. This is one of those volcanic ash layers. Now I'm going to move over here a little so she gets more light there. One of these volcanic ash layers from a freshwater lake out in southwestern Wyoming. And you can see this is more dimpled, a lot of little spots through here and not so much up here. That's because the coarser bits of volcanic ash settled out first, and then finer and finer ash settled out into the lake here. If we turn this and rotate it to this side, I look at this, and here's that coarser bit of ash that settled out. There's some thin layers of fine stuff, so there's a little bit of break sometimes, maybe between eruptions over a number of days or weeks. But here you can see some layering like this, and that means the ash was carried by water this direction through here and settling out. And then this is just all chaotic looking up in there. Because of maybe an earthquake happened and it jiggled all the sediments up. Anyway, many things to talk about. This is some coarser volcanic ash with a lot of little crystals in it. Let me get it in better light. That was erupted closer to the actual volcano. These are not samples from New York. This one's from Montana. And you can see the dark and sometimes white or clear crystals inside it, not just the ash like in there. Anyway, much to look at around here. Let's wander somewhere else. Oh, here's an interesting thing here. This is a relief map of that Catskills mountain area right through here. Albany would be up there. Here is the Hudson River just off the edge of the map right there. It cuts right about there. So this is the Catskill Escarpment, where the Catskills really rise up high out of the Hudson Valley. A town named Cairo here. The famous Woodstock is right here. Here are some large reservoirs that feed water into New York City. But you can see the low areas are the blue colors going to whitish, and then grading up through greens to kind of golds to the oranges, and then white on the high peaks. There's the highest peak in the Catskills. And when I'm out in the field, some of the time I'm walking along these ridges here looking at the rocks, or coming up from this valley here up to Wittenberg Mountain and over to Slide Mountain, studying the rocks up there in the Catskills. Very famous fossil forests have been found around Gilboa here that's been known for over 100 years, the Gilboa fossil forest. But a new one was found in around Cairo about 10 years ago. And right now, that's the oldest known forest in the world. Paper came out on that around at the beginning of 2020. Many discoveries. This whole area of the state of New York, the geology of it is still very poorly known. Very poorly known. Anyway, maps, charts, all kinds of things to look at. Let's wander over here. All right, this is part lab also. And here's a binocular microscope, which you can turn the lights on. And with this tray underneath, I can take this piece of rock that has a lot of pebbles, what used to be gravel with sand, and take a look at it up close to see what it's composed of. What are those different grains, those different pebbles made of? Different kinds of rocks that weathered out of the Appalachian Mountains. One of the things, sometimes with rocks, you see things better when they're dry, but sometimes you can see things much better when they're wet. So, in this case, I would put it under the scope here, and I would look down on the rocks, take this pebble right here, for instance, and it has a very different character from most of them. A lot of them are kind of whitish, or red-tinted whitish, like there. Those are quartz. This one here, when I look at it, I can see that it's reddish, but it's full of sand grains. So that's a piece of sandstone that eroded out of the mountains. I know you can't see the details there, but so that's another thing that I do in my office. There's a lot of rocks in my office, and over in the rock collection, the sedimentary rock collection. So here are some various rocks that I've been doing some research on. With these, several things. You can see the rock here. I have cut them in a rock saw. And a rock saw, it just cuts very slowly going through a rock. You'd be surprised. You think of how dangerous it is to get near a blade that is cutting wood, right? But for a rock saw, you can put your finger right up against it, and it doesn't hurt your finger. It just slowly grinds through the rock over time. And then I get a fresh surface to look at that if I spray it with water again, I can see the details more. But also with this rock, I sent it off to get a piece of the rock shaved down so it's like a stained glass window. And I can look at and figure out the minerals that are in this rock that way. I've also sent some of this rock to a lab in Arizona, and it crushes the rock, and out of it it gets all of these little crystals of a mineral called zircon, which is sometimes known as a semi-precious stone, semi-precious mineral, but they can get dates off of those little crystals. And with that, they can tell me what different sources went in to make this sandstone that eroded off the Appalachian Mountains. Some of those crystals will be about the age of the Devonian rocks here, so maybe they came from volcanic ash layers. But some of them, a lot of them would be like 1 billion to 1.2 billion years old, same age as the rocks in the Adirondack Mountains in northern New York. Some of them would be about 2 billion years old, and that was from long, long, long before even the mountains of the Adirondacks, the rocks in them, formed. And even have had a couple that were 3 billion years old. And there's a lot of details of what that tells us, but basically it tells us what different pieces of land that now make up North America, that they came together and helped form the larger North America that we have now. It wasn't always this big. Anyway, yeah, that's just a few things. And I'll let Nicole do another sweep around the office here. This is a place where a geologist works. And to be a geologist, you have rocks around that you're studying. You have fossils that help tell you more about the rocks. There are books and tons of scientific papers that I have to read to know how people have understood things before. There are notes from my fieldwork and my own research. And just many, many things around that I constantly am looking through to better understand how New York became New York around 400 million years ago. Part of that time, New York covered by shallow seas, and part of the time above sea level, with Earth's first forests. Thanks a lot for coming by.